Welcome to the first Labconscious webinar. We're excited to host our first speaker, a PhD candidate in neuroimmunology, who will share an initiative to optimize protocols, test new technologies, and produce guides for scientists to improve the sustainability of laboratory work.
Hello, everybody. My name is Penndorf, and I'm so glad to see you all. Actually, I'm calling you from Europe to talk to you today through NEB TV, and I'd like to thank all of you for being here, not just for taking the time, but also for being open. If you wouldn't want to master new challenges, you wouldn't be here. But I think this is what it takes to take your science to the next level. And of course, I hope you're all fine. You've had a good day so far. You're not too stressed. I'm saying this because I have been quite stressed during my bachelor thesis. However, this was also the starting point of me working sustainably. So when I was a young and aspiring student, the first time in the lab was during my bachelor thesis, and I was working in protein science. And I'm telling you this because I was freaking out. I was sweating. I was afraid because I was cleaning up my proteins, and this waste container was getting more and more filled up. And it didn't look good, and I have had no clue where to put it, but my supervisor wasn't there, and it was super embarrassing, to just admit that I have no clue. I couldn't do nothing for the last hour because I had to stop. And it was at this time actually that, the love for sustainability started, because I realized when it would work more sustainably, that means wasting less liquid for washing my proteins, I could maybe get around this issue. And this is how it all started, basically. And I'm here today to discuss with you how to optimize research, because I've been in the lab myself. I studied biochemistry and molecular medicine, and then conducted my own research in neuroimmunology. And of course, part of all of this was what we all experience, optimizing our protocols, right? But sustainability was another passion of mine, which fitted quite well, because here, together with some friends, we have been organizing conferences called the Green Laboratory Work conferences, and we crafted some educational pieces and some protocols for people to optimize how sustainable they can be in the lab. And this then actually, over time, led to us wanting to share what we have found out. And this is also why today I will talk about increasing lab efficiency up to 71% through sustainable science. That means we will discuss not how to change what you do, but rather how to improve your efficiency and how effective you are through approaching your protocols with a sustainable mindset, you might say in a sustainable way overall. And today we will talk about efficiency and sustainability, not because I think it's a new topic to you. Most of you probably will already have been handling with those, but because there's lots of room to improve. And I want to bring you some numbers to just bring this point home, because it was estimated that a single researcher might produce up to 950 kilograms of plastic waste each year. If you think about how many researchers there are today, I think this is quite some amount. And during the COVID pandemic, just until August 2021, probably 15,000 tons of plastic waste due to PCR tests ended up in the ocean. Yes, not in landfills, not recycled, but just going straight away into the ocean. And if I think how many PCRs I've been doing in my life, I am worrying a little bit, to be honest. And for everybody working, for example, in bioinformatics, if you run a simulation on the tobacco mosaic virus, you want to predict it for 100 nanoseconds, you might produce up to 100 kilograms of carbon dioxide equivalent. And again, I think these numbers are quite impressive. But of course, I've shown you these numbers because there are ways to, improve what we are doing. And this is why we hosted the Green Laboratory Work conferences, on which we would educate researchers on, you might use metal and glassware instead of single-use plastics just to reduce your footprint. By the same token, recycling waste might be an idea because you can take the packaging of the consumables you receive, and instead of throwing them just in any bin, which might be, autoclave, taking lots of energy and not be recycled, throwing them in a plastic bin, and so giving it a chance for a second life, you might say. Also, share your equipment, right? This is a great way to reduce costs, but also to meet new people, and of course, avoid that you have rooms crowded with equipment that you will never use again. And finally, exchange solvents. When it is possible, use solvents and chemicals that are less hazardous, not just to protect your own health, but also because, when they end up on a landfill, you might hope that, nature thanks you for basically not intoxicating it. However, what then appeared is that all of those started to fade away for very good reasons, actually. So some scientists struggled with time. They said they haven't had enough time to actually learn and implement those new practices. Some others said, the expertise was missing. They didn't know what exactly to do and how to implement it. Some lab managers were afraid that they haven't had enough money to actually buy, these more sustainable products because they would be more expensive. And yet others were afraid of impairing processes. They said sustainability doesn't belong in the lab because it will basically screw up everything we do. And so many of these challenges, displayed this problem of, on the one hand, you have your science, and on the other hand, you have sustainability. And whatever you do for one, you will impair the other. And this was, to our mind, the core of the entire problem. So since our team is made up by researchers and scientists, we could feel all of these concerns, and we knew it required a new motivation. And people were asking for reliability and feasibility, something that many groups have not really considered because some of them are not researchers. And since these things are not obvious, it might be more difficult to actually come up with them. But since we were able to synthesize basically our experience from the lab and our passion for sustainability, we saw that the most sensible approach is to make science more efficient through sustainability. So to take a sustainable approach to optimize and rethink our protocols, to cut a long story short for now. And this is why, coming back to this slide, connecting science and sustainability allowed us to share our insights and found re-advance. Because here we want to connect research associations and scientists to sustainable laboratory practice in order to improve science, again, by taking sustainability as a way to do science, not to change what science is about, but rather to change how we conduct our work every day. And with this in mind, let me share you how you can increase your efficiency up to 71% because we've been doing it with our own protocols. And you will be probably surprised how simple and easy it is. This is the basic strategy, right? You take a sustainable approach, you improve efficiency, and just then you reduce the footprint. So sustainability is not the main concern. It is just the methodology, basically, you apply. And the 71% apply to multiple things. Let's talk at first about money and waste. A fairly simple but efficient strategy is to use small tips instead of serological pipettes. Because as you can see here, you can save a lot of waste. If you just have to pipette 2 mLs, you don't need a serological pipette, especially because those are very hard to recycle since you have this little, like Q-tip-like wool on the very top. And another tip is, just try to use tips twice. I mean, if it's possible and you do not contaminate anything because you already have designated tubes, you might be able to reuse a tip by, for example, putting at first all the buffers and then your samples. And of course, this can lead to quite some efficiency here. Me personally, for example, I've been able to reduce my plastic waste by more than 70% when transfecting neurons, right? So bringing DNA into neurons in culture, because I was using qPCR tubes instead of 1.5 mil Penndorf tubes to mix my DNA because I only had a volume of about 20 to 30 microliters. And by the same token, these plates I would use to mix my chemicals, I could use smaller ones. And so this is super simple, but it saves you lots of money, and to some extent, it saves you lots of time, because if you work in a sterile hood, not everything is crowded. If you have smaller consumables, you will need less space, and that, of course, also improves then the airflow and therefore the sterility. So you can see everything is basically connected just by such a simple tip. Another important factor is to rethink to reduce. I want to bring you a fairly great example which actually improves your research. Let's say you have two treatments, A and B, and then you want to prepare slides for microscopy. And then just to have a nice overview, you might set them up like this, and you're happy because now you have a treatment control, right? Treatment A and treatment B. However, let me tell you, if you use a sustainable approach, you might think about, all right, can I put 3 samples on these slides because then I can use 1 slide less? And therefore, what you will be able to do, as shown here, is that, you have 1 less slide that ends up on a landfill because there's nothing really you can do with it. You can't really recycle it. But you will also control now for treatment and for staining. Because let's say your treatment, might, I don't know, shed a certain part of a protein, or it might mask where a certain antibody will bind. And you would never have seen it if, for example, your treatment B would have done so. But now, since you have A and B on 1 slide, you will be able to see that, a fainter staining might come from the treatment, in terms of chemical effects, not necessarily by biological effects. And then changing habits. On the one hand, it was estimated that saving your data in clouds might take 1 million times more energy than on local hard drives. And this again connects to good scientific practice, because I see many people, storing their data on a cloud and in 2 different files or folders because they think this is safer. But, good scientific practice tells you no. Take 1 and put them in a cloud and 1 on a local hard drive. Because if the cloud dies, it doesn't matter how often it is in there, because it will be gone. And in this way, good scientific practice, you can save your data more reliably, you save energy. But changing habits also refers to, when you want to optimize how to do your SDS pages, right? You can do multiple jails at once and then even, freeze them. Let's then put them in the cooler so that you can use them the next day. Saves you lots of time. You might be able to run multiple experiments in 1 day instead of, having every day to prepare your SDS gels again. We have a protocol for sustainable SDS pages, for example, on our website. And it's really these small things which can speed up your processes because you rethink them and because you will be more engaged at work. You will be more focused because there's a new element you add to it, basically. So lots of people often ask then, how do I actually, with a concrete protocol, reduce the time it takes me? And obviously, you need to craft your approach to your science because you're the safeguard of the quality of your data. But indeed, for example, on our website, we have some guides, to optimize basically your pipetting scheme to be faster, to optimize your statistics and your planning, to basically do less experiments with a higher power, a higher impact, and therefore saving times. But also there are lots of, articles out there. This one for bioinformatics. There are some which give you concrete ideas, for example, when you work in microbiology. And of course, although they are not publications, but guides that show you, or rather inspire you, what you can do yourself. And unfortunately, we already have to wrap up. But I hope you could see that, the sustainable approach is not changing what you do in science, but how you do it. And therefore, you can improve efficiency by reducing your expenses, right? Less waste means less new orders. Saving some time, improve teamwork when you basically reach out and work together with your lab mates. It might mean improved experimental design, and then, of course, as a result, a reduced footprint. And to let you go with something very concrete, 5 questions. At first, ask yourself, where do you leave a footprint? Not just in terms of carbon dioxide or waste, but also where do you spend most of your time? What do you spend most of your money for? All the factors we have discussed, because If you can find a vendor that is closer to you, the articles will be faster at your lab, and of course, it might be somewhat cheaper. And this can help you not just in terms of time, but also reliability, as we have seen during COVID. And obviously, this is more sustainable as well. So don't let culture, but rather efficiency, run your lab. Secondly, ask yourself what is necessary. I love this picture here because when I was handling my samples for microscopy, I had to dehydrate them with a sucrose solution and then wash them with PBS. The point here is that you don't need tips, you can just pour the chemicals because they're not toxic, and whether you wash in 2 ml or 2.2 ml doesn't really make a difference. And thus you save time again. Ask yourself, can I optimize this step? Yes, for very complex ones to improve your data quality, but also for very mundane steps. Because as you have seen, it is the combination of doing multiple things, even small, even trivial actions, which then add up to improve your efficiency. And so if you ask yourself, can I be faster here? Can I make it more reliable? It might actually help you, because otherwise you would just have done it without even thinking about it. How can you share your passion? You see, it is more fun when you do it with other people. You will get their inspiration, you will get new energy, you will get support in hard times. And of course, the more people we are, the bigger our impact in terms of sustainability as well. And finally, why shouldn't you do it? We are often held back by fear, by concerns, but you can just go for it. Lots of impairments in efficiency come from sticking to a culture, sticking to a habit. And I hope that this presentation showed you that there are many small things you can do to improve all of these things. And the only thing it takes is you trying it out. Take an empty plate, pour some water in it to see that you can put a PBS. Whatever it is, just take the first step and embrace it. And so this is it from my side. Thank you guys so much for your time. Here's everything you need to know. And if you have questions, always reach out to us, right? This was just a primer to how sustainability can improve science. And if you want to know more, this is where you got to go. And as a special giveaway for the NEB audience, we offer a few seats in our innovation assessment team, where our teams with scientists from different backgrounds, different ages, assess the latest innovations from startups and companies. They come to us, present them, and then we discuss them. So if you want to be the first one seeing the latest innovations, to basically have a say in what is going to be developed, check it definitely out. And again, this is it. Thank you so much, and wish you a beautiful day.
Thanks, Patrick. Can I ask you a couple of follow-up questions?
For sure, happy to answer them.
So what kinds of scientists would you like to join the Readvance Innovator team, and what are the perks for team members?
Yeah, that is interesting. I would say the innovation assessment team is basically for everybody. We established a small team that is very close with each other, so everybody knows each other, because this personal element is rather important to us. However, as I just said, everybody's welcome. We look for a variety of backgrounds and levels, meaning from bachelors to professors, as well as people from any geographical location, any age, because these startups and companies which are presenting to us are interested in getting a broad range of feedback, because these multiple perspectives enable a thorough understanding of the innovation, but also how to tailor the communication about it to these different audiences. And in terms of perks, I mean, obviously the team members will get to see the latest innovations, maybe even before they hit the market. So I think this is something very interesting in itself. But joining a team with so passionate scientists is often interesting, and I have to say also inspiring by itself, by just having these people surround you. But obviously, people will be able to get a deeper look into sustainability. That means into these applications, but also which challenges go along when implementing them. So if anybody is interested in getting to know more about sustainability, but also how companies actually develop these innovations, try to market them, try to implement them, then I think they are a perfect fit.
And where do you see the most potential in the lab for saving time in protocol optimizations?
That is an interesting question for sure. Although obviously one will arrive at different answers for different protocols, I think to answer it right here and right now, it is mainly these steps which seem very trivial. I think it is really the things we often overlook because we don't think they are quote unquote important enough to reconsider. To give some examples, I would say these very simple questions, such as in which order do I add the solvents? How do I order my washing procedures? And of course, how do they make sense for the tissue at hand, as well as reconsidering incubation times, can often be big time killers because when we start to reconsider those tasks, you will really see how you can stack them into each other. Because in a 5-minute incubation time, you can prepare a buffer or you can start to preheat a water bath instead of running it all times. And so I would say it is really the things basically that are really worth reconsidering because often they just go unnoticed because you get the protocol and you think, all right, it works, but you don't really think about making it more efficient or to optimize it.
That is too true. So, Patrick, thank you so much for sharing your efforts and for your passion for sustainability and science.
Thank you so much, Nicole. It was a pleasure, and I'm so happy to be able to venture with Readvance to make science a little bit more sustainable.